Hello, in this video we're going to be talking about that word critique. What do I mean critique? Well, asking questions and understanding which questions to ask to identify where maybe falsehoods are creeping in. And these could of course be unintentional falsehoods. Now, this means I want to introduce you to questions to ask in order for us to not take truth for granted. And this is particularly important in this era of fake news and hyperbole that's all around us. And again, even more important now in this era where science and data are taking a more central role in our lives. So I think this is even more pertinent than ever before now. So I'm excited for this. So we see pieces of data analysis and pieces of probability theory everywhere we go, and especially these days on the social media. So here's a collection of sort of snippets that I've seen on Twitter, Facebook, or in newspapers, which I think illustrate my point really well. So you see these sort of stuff, nearly every day if you're on Twitter and Facebook and stuff. But I've just picked and chosen a couple of these which really emphasize my points here. So I'm going to go through each of these examples and start breaking apart what they're trying to say and try and understand where these authors are coming from. So this first example, here are a couple of tweets from the QI Twitter account. And this is quite typical of what they tweet. So this first tweet at the top: a third of the alcohol sold in England is drunk by about 4% of the population. That's very typical of the kind of things they tweet, and you can see it gets a lot of retweets as well. Nearly 3,000 likes here, and this information spreads really fast around social media. So what I want to ask you, if you were given that tweet, is what do they mean? What is that actually saying? What's a third of the alcohol sold in England is drunk by 4% of the population really saying? And do we think that the 3,000 people who have liked that really understand what they're saying? Now, I'm not trying to say people are dull at all. What I'm trying to say is that this is a lot of people deliberately write stuff in percentages and ratios and so on in order to confuse people. And this is a classic example of that. The other thing I would ask you is, where are their source? They haven't referenced anything here. They could just be making things up. Now on the bottom there you can see another tweet by the same people. Actually, these were exactly the same day, straight after one another, where they did give a source. So here they're saying that in this particular article in the journal Neurology, they found that people with excess fat around their middle have smaller brains. Now, what I'd like to ask you is, they've given us the source, lovely, but how many people are going to click on that source? And do we really believe that these people who have composed this tweet have read a neurology academic paper, understood it enough so that they can summarize its findings in less than 140 characters? I would think some misunderstanding is going on, and we, by reading this tweet, are only getting that misunderstood message. You'd also have to ask with stuff like this, is there some sort of spin involved as well? There may be an agenda behind this, excess fat, smaller brains. There might be some sort of agenda behind that. So we need to ask, is there misunderstanding? Is there spin? So some of the stuff I've highlighted in these sources is, where are the sources? Is there any sort of spin or misunderstanding involved? The next example comes from Facebook, comes from the Daily Mail, posted this on Facebook. There was an article, it was obviously quite a short article, 1 minute to read, which the headline states, if someone drinks their coffee black, they are more likely to be a psychopath. So again, the very first thing I'd ask you is, what does that mean? Right? Are they saying, well, they've said it quite clearly. They've said, if someone drinks their coffee black, then they're more likely to be a psychopath. That doesn't mean more psychopaths drink their coffee black. They are two different things. If you're a psychopath, you drink your coffee black, is different to if you drink your coffee black, you're a psychopath. The other thing I'd like to highlight here is, just because you've read this, a lot of people might look at this and go, oh well, drinking your coffee black makes you a psychopath. There's no causation involved at all here. Even the other way around, if you're a psychopath, then that makes you drink your coffee black. Again, there's no causation here. Just because two things are correlated doesn't mean there's a causation. So I've highlighted that here. The last thing I've highlighted here is we don't know the effect size. And what do I mean by effect size? Well, if someone drinks their coffee black, they're more likely to be a psychopath. How much more likely? If it's only a tiny fraction more likely, then why is this even news? There's no indication here of what the effect size is. And I think a lot of people, I'm guilty of this, you are definitely guilty of this. Sorry, I didn't mean to accuse anyone there, but you are definitely guilty of this. We share these things, we retweet these things without reading the article. We retweet headlines, and that means we're only getting the misunderstanding, and we're only spreading the misunderstanding, and we are all responsible for propagating fake news. Of course we are. The next headline I found come from a news website, actually, and this news website says, Americans are more likely to die from an opioid overdose than a car accident. And this was meant to be sensationalist news. Oh my God, what's going on here? America's in crisis. More people are dying from opioid, more likely to die from an opioid overdose than a car accident. But there's no mention at all in this headline of what the condition is. And I'll talk more about, when we go into probability theory, I'll talk more into what is a condition. But what I'm asking here is it just that if you're an average American person, you are more likely to die from an opioid overdose than a car accident? Or is it, out of all the people who had an opioid overdose, a certain percentage of them died, and out of all the people who had a car accident, a certain percentage of them died, but you're more likely to die if you've had an overdose than you are to die if you've had a car accident? If that's the case, then why is this news? You would hope that if you have a car accident, you're less likely to die than if you have an opioid overdose. Headlines don't tell the full story, and quite often the articles don't tell the full story. Again, what is the condition? This next example is a tweet from a very is a retweet from a very well-respected historian, Dan Snow. And there's a humorous caption, see if you can pinpoint the timing of Trump's tweet, and the image is a plot of some sort of stock level over time, and there's a sudden drop in the stock level, and the humorous implication is that maybe Trump caused this. I don't care about that causation aspect now, because that's clearly a humorous example, but what I'd like to emphasize here is look at the axes of this graph. The y-axis doesn't start at 0, starts nowhere near 0 actually. The y-axis actually only spans about 1,000 somethings. There's no units, but 1,000 somethings. I'm guessing that's something to do with price. And the x-axis is only 5 hours long. There's these gyrations throughout time, and then there's a sudden drop. But what does that mean? What's normal here? Is this just a normal fluctuation that happens every couple of days, every 5 hours or so? Or is this a massive fluctuation because of whatever? We don't know. So there are misleading axes here, and we don't know what is normal. Most people reading this comes from historical Twitter. Most people who are interested in historical Twitter won't know what's normal with the stocks, so would misinterpret how this is interpreted. And the final example I want to show is a really nice one actually. The headline of this article, this is in a newspaper, is 9 out of 10 online CVs reveal multiple spelling errors. And that looks like the kind of thing which I could go, ooh, hang on, did they think of this? Or that sounds misleading or whatever. But what's really nice about this is that as you start reading the article, they tell you exactly how they worked this out. This is a lovely article. They say there was a review of 20,000 CVs submitted online. And that's a big sample size. And then they say how many had spelling errors and how many didn't. And they tell us and they walk us through exactly how they came to these conclusions. So this actually is a very nice article. Here's another tweet which I want to spend a little bit more time talking about. Here's a now deleted tweet, and I believe this person to be just an anti-vaxxer troll. Okay, I don't believe they were serious in any of this. But this tweet stated some facts, and these are facts, stated some facts that tried to give the impression that vaccinations was a failure. Okay. So it says a study in paediatrics published in 2019, so very relevant, reported that 82% of paediatric pertussis, I don't know if I can say that correctly, but that just means mumps, right? Childhood mumps. So 82% of childhood mumps cases identified in the state of California were children who had been fully vaccinated. The state vaccination rate is 98%. And then he's gone on to say, well, wasn't herd immunity meant to protect us all? Isn't this just a science failure if so many vaccinated children are getting mumps? I'd like you to have a think now. Pause the video if you want. I'd like you to have a think. Is he onto something? Or is there something else going on here? I'm now going to start to analyse this in a way that you will be able to do at the end of this course. And let's have a think what exactly this man is saying. Now, I have looked online, and the World Health Organization says that mumps vaccines for children are 90% effective. And this man has gone and said the state vaccination rate is 98%. So let's have a think. Choose a child in the state of California at random. That child can either be vaccinated or not. Either be vaccinated or not. I'm going to use this symbols to use. What is the probability that they are vaccinated? Well, in California, that would be 98%, and 2% chance that random child I chose is not vaccinated. Once you're vaccinated, you live your life, and you might come into contact with someone with mumps. If you're vaccinated, vaccines are 90% effective, so you would expect to have mumps with a rate 10%, and you expect not to have mumps with a rate 90%. Now, if you're not vaccinated and you come into contact with someone with mumps, you're going to have mumps at a rate of 100%. You're definitely going to have mumps if you're not vaccinated because you have no protection. Out of the whole population of the children we are talking about, what percentage of them were both vaccinated and had mumps? Well, it's 10% of the 98%. So 10% of the 98% is 9.8%. And what percentage of them didn't have mumps? Well, that's 90% of the 98%, and that is 88.2%. And what proportion of the population were not vaccinated and had mumps? Well, that's going to be 100% of the 2%, so that is 2%. You can double check if we've done this right. You should be able to add all three of these up and get 100%. That's all the children in California accounted for. Now we can immediately see that there are a much bigger proportion of the children who are both vaccinated with mumps than not vaccinated with mumps. Why is that? Because so little people did not get vaccinated. This man is saying that 82% of all mumps cases were people who were vaccinated. So out of all the people who had mumps, what is the percentage who were vaccinated? Well, 99.8% of the children in California had mumps and were vaccinated. Out of all the people who had mumps, that was 9.8%, add the 2% who were not vaccinated, and that gives us, do this on a calculator yourself if you don't believe me, that gives us 83.05%. So if vaccines are working exactly as the World Health Organization tells us they are, we would expect 83.05% of mumps cases to be children who are vaccinated. This guy said that 82% of mumps cases were children who are vaccinated, which is very close to the theoretical. So all this man has done in trying to troll the world with his anti-vaxxer rhetoric has just proved that the vaccines in California work exactly as the World Health Organization say they do. Finally, let's have a look at some pieces of data analysis. We've looked a lot about probability. Now, this is some fake data, but imagine that you were presented with this graphical form of data. One of the aims of this module, data literacy, you should be able to read and understand what's going on here and be able to draw conclusions from it. So here is a scatter plot, a bar chart, and a box plot showing the relationship between the spending, satisfaction, and gender of a group of shoppers. What conclusions can we draw from this data? Well, from the bar chart, we can conclude that in general, more people were on the satisfied end of the spectrum than the unsatisfied end of the spectrum. From the scatter plot, we can see a trend. We can see that as more people were spending, the more satisfied they became. Now, we don't know at all if spending more made them more satisfied or that they were spending more because they were satisfied. We don't know. We don't know if there's any sort of causation here, but we can say there is a correlation between spending and satisfaction. And what is the box plot telling us? That box plot, and don't worry if you don't know how to read this yet, this is all part of this module, but that box plot is telling us that in general, females spent a lot more than males. What other conclusions can we draw from this data? Well, not much else, and that's kind of the point. We need to be able to look at this bit of data analysis and not make conclusions which are not true. It's very, very tempting to go, we know females spent more than males, we know that the more you spend, the more satisfied you are, therefore females must be more satisfied than males. But we don't know that. That would only be true if some of these variables, I think satisfaction and gender, were independent of one another. But we don't know that. Thank you. I hope that's given you some sort of an idea of the kind of stuff we'll be doing in this module, and I hope that's given you an appreciation of the importance of being able to ask questions and the importance of being able to critique other people's data analysis and just to think deeper about what is being said in the world.